Hello, everyone. This is Dr. Prato. Thank you for coming to class today. I will be covering an introduction to logarithms and some of their properties. So, to start things off, let's talk about what a logarithm is. Simply put, the logarithm is the inverse function of an exponential. Now, last class we talked about that if a function is one to one, then it has an inverse. And the last thing I showed you was that the exponential function uh, passed the vertical and horizontal line test, which means that the exponential function, is one to one. Therefore, it has an inverse. So the only question left is what should we call that inverse function? And we call that the logarithm. So put simply, if we have a function f of x, which is equal to a to the x, then the inverse of that function, we call it log base a x. Now, why do we call it base a? Because in this expression here, a to the x, a is the base. So we say that this is log base a x. Now, in your calculator or somewhere else, you may see that this x is in a parenthesis. That's acceptable. You can write it with or without parenthesis. People will know what you mean. Let's talk. Let's go ahead and graph a simple exponential function, um, and then from there we'll work out what the inverse function would look like. So we need to pick some points for x. Let's pick 2, 1, 0, and -1. So let's plug that in. What's f of 2? That's 2 to the squared, and that's 4. What's f of 1? That's 2 to the first power, which is just 2. And f of 0 is 2 to the 0th power. Now, this is where people get a little confused, but slow down. Let's look at this rationally. When we have 2 squared and we go down to 2 to the first, what's that relationship? Well, we're dividing by 2. So 4 divided by 2 is 2. We're going to continue that same relationship. What's 2 divided by 2? That's 1. You see that? So 2 to the 0th power is simply 1. And let's keep on going to f to the -1. What do we need to do with that 1? We just need to divide it by 2. So we get 1/2. So let's go ahead and graph this. 2 comma 4 should be right about here. 1 comma 2 should be right about there. 0 comma 1 right about there. -1 comma 1/2 is about there. So as the function goes from left to right, it goes up to positive infinity. But as it goes from right to left, it actually gets closer and closer and closer to the x-axis, but never touches. Let's go ahead and talk about the inverse, f inverse of x. Now, from here, we see that it needs to be the log. What's the base? The base should be 2x. And where should we get our inputs? I think we should just pull them right from here. So that'd be 4, that's a 2, that's a 1, and that's a 1/2. And how do we find out what the outputs are going to be? Well, those are right here. So that's 2, 1. I think you see the pattern. 0, -1. Let's go ahead and graph those. 4 comma 2 is right about here. 2 comma 1 is right about here. 1 comma 0 is there. And 1/2 comma -1 is right there. Now this logarithm also doesn't look like it, but it actually does go up to infinity as you go from left to right, but just goes very slowly. And if you go from right to left, it actually gets closer and closer and closer to the y-axis without ever touching it. Now, because this is their inverse functions, that means if we graph the line y equals x, it's a little messy, but if we graph that line y equals x and we fold this graph over that line, these two curves will perfectly fold onto one another. Now, that is what the logarithmic function is. It's the inverse function of the exponential function. But this feels a little too abstract. Let's get some hard examples. Now, there are a lot of when dealing with logarithms, you can get a lot of weird, irrational answers, but there's a lot of nice answers also. Let's look at log base 3 9. Now, when we look at this, what I want you to be thinking is, okay, I have 3 and I need to raise it to some power to make it 9. What's that power I need to raise 3 to to make it 9? And the answer is 2. So the log base 3 9 is 2. That's all this is asking us. I know it sounded confusing, but it's really not. It's this all this is asking us is, what power do I need to raise 3 to make it 9? The answer is 2. How about log base 5 125? What power do I need to raise 5 to make it 125? Well, that in this case it's 3. So log base 5 125 is 3. What about log base 10 100? Again, what power do I need to raise 10 to make it 100? The second power. Now this one is fun. Also, log base 8 4096. Well, what power do I need to raise 8 to make it 4096? It's actually 4. What about log 2 1 half? What power do I need to raise 2 to make it 1 half? Remember from the last page when we raised 2 to the negative 1 power, that is just 1 half. That's why log base 2 1 half, that's just going to be negative 1. All right, let's talk about some properties of logarithms. The first property is called the product rule, and that says if you have the log base b x y, you can break up these two terms into log base b x plus log base b y. And the beauty here is that the logarithm actually turns multiplication into addition. So here, log base 327 times 9, that's just going to be log base 327 plus log base 3 9. Log base 327 is just 3 plus 2, which equals 5. The next property is called the quotient rule. And what this does, it turns division into subtraction. So the log base b of x over y just becomes log base bx minus log base by. So the log of 327 over 9 just becomes the log base 327 minus the log base 3 9, which becomes 3 minus 2, which is 1. And the final property I'll be discussing today is the power rule. The power rule. And that simply says that if we have log base b x to the y, this y here gets to hop out in front. Y log bx. So log base 3, 9 to the 27th power just becomes 27 times log base 3 9. So that becomes 27. Now log base 3, 9. That's just our friend 2. And 27 times 2 is 54. Thank you so much for spending the last 15 minutes with me. Um, if you have any questions, you can come see me. You can come see me in my office, or we can talk before or after class tomorrow. Thank you so much.